Okay, welcome back everybody. So today we have Adlam from Chapman University who's going to talk about how do we observe relational observables. So please, Emily, the floor is yours.
Hi everyone. So we heard a fair amount about the problem of time in quantum cosmology yesterday, and so I am sort of going to talk about the problem of time, but I want to sort of start by approaching that by talking about relational observables just in the classical context, because I think there are some sort of conceptual issues in the classical context that are perhaps not yet fully resolved, and resolving those are hopefully going to help us get closer to a solution to the problem of time in the quantum context as well. So I'll begin by giving a brief review of relational observables, and then I'll explain why I think that there is a sort of open question about how exactly we're supposed to observe them. I'll talk about externalist versus internalist solutions to that question. I'll talk about the issues raised by the fact that we experience ourselves as being located at a time. I'll then argue that I think some of these issues can be resolved by moving to a more agential conception of conscious experience. And finally, I will eventually arrive at quantum mechanics, at which point I will finally talk about the measurement problem. So relational observables arise because of the fact that diffeomorphisms are a local symmetry of general relativity. That leads to a prima facie problem because it looks as though the determinism of the theory is lost, because given any solution to the Einstein equations, we can generate another solution by applying a local diffeomorphism somewhere in the middle of time. And so the initial and final states, together with the laws, seem like they're not sufficient to fully determine the course of history. So the usual interpretative move that we make here in theories which have this kind of problem is to simply restore the determinism by stipulating that all histories related by a symmetry transformation are physically identical. So those diffeomorphism-related histories are not, in fact, different histories. They're one and the same histories under a different description. So that gets our determinism back, but does lead to some other conceptual issues. So in particular, it follows from this interpretative move that any variables which can be expressed as local functions of the coordinates, because they're not invariant under diffeomorphisms, they can't be regarded as physically real. They're physically meaningless. So we sort of say that they are not observables, but that term doesn't really have anything to do with the observational capacities of any particular observer. They're not observables because they're just not real at all. They're not physical. So that leads to sort of a prima facie puzzle because it sort of seems that most of our experience of the world is composed of observations of localized variables, and perhaps the most intuitive way of formalizing those variables is to express them as local functions of the coordinates. So the question is, how are we supposed to connect our experience of the world up to the formalism of the theory if local functions of coordinates are not, in fact, physically real? So there are a variety of different problems in this vicinity. One is what I'll call the formal problem, which is about can we recover enough physically real structure in a theory like this in order to be able to formulate classical and/or quantum physics in appropriate regimes. There's also what I'll call the experiential problem, which is about can we understand how our experience is supposed to make contact with the world in a theory like this. There's also the problem of time, which applies specifically in the quantum context. This arises in the quantum context because the formalism that we typically use to quantize a constrained theory has the consequence that we seem to have to say that no observable which undergoes change in time can be physically real. So it looks as though we have problems extracting any kind of time or change out of that kind of theory. I'm not going to talk about the problem of time in most of this talk because I think we need to resolve, there are some problems in the classical case that should be resolved, and resolving those problems will hopefully also help us to resolve the problem of time in the quantum case. So in either the classical or the quantum case, in order to solve the formal and/or experiential problems, a sensible starting point is presumably to identify some variables which are observables, which could be used to construct some kind of physically real structure. And there are two obvious classes of observables variables we can use here. Highly non-local quantities, which are defined over the whole of space-time, are observables. And relational quantities built out of correlations between field values are also observables. So because our experience tends to be quite localized, it looks like the first kind of variable is probably not that useful for making sense of our experience of the world. So most approaches to this problem have tended to focus on the second kind of observable. So those are the relational observables, and the thought is that using relational observables, we can extract the right kinds of structures to make sense of classical and quantum physics and our experience. So there are a variety of different formalisms people have used to study relational observables. I will discuss two of them in more detail, but I guess the key point I want to make here is that most sort of work within physics on this problem has largely focused on the formal problem, and we do seem to have a number of different approaches which, at least at a formal level, allow us to extract the kind of structures we would expect to see in order to be able to formalize classical and quantum physics. So arguably we have some good approaches, or at least good progress towards solutions to the formal problem. But a solution to the formal problem is not automatically a solution to the experiential problem. It doesn't necessarily help all that much if you can extract structures which look like they correspond to quantum or classical physics, but you then can't show how those structures could possibly get connected up to the actual experiences of observers like ourselves. So the question I want to focus on in this talk is, given that we have these things which appear to solve the formal problem, how are they supposed to solve the experiential problem? So I'll talk about two particular formalisms which have been used to solve the formal problem. One of them is the idea of partial observables due to Carlo Rovelli. So Rovelli defines partial observables as physical quantities to which we can associate a measuring procedure leading to a number. And he defines complete observables as observables which can be predicted deterministically or probabilistically by the theory. So the terminology is a bit funny here, but basically partial observables are not observables in the usual sense of that word as we use it in diffeomorphism-invariant theories. Partial observables are not themselves diffeomorphism-invariant. They're not considered physically real according to the usual interpretation of these theories. But they are the kinds of variables which we would perhaps naively imagine ourselves as measuring, so things like the positions of objects. Complete observables, meanwhile, are the ones that are observables according to the standard interpretation of the theory. So complete observables are physically real, whereas partial observables are supposedly not physically real. So the point Rovelli wants to make here is that although partial observables are not observables, the relations between partial observables are usually complete observables, and therefore you can plausibly sort of get out a dynamics for the partial observables by expressing dynamics in terms of relation between partial observables, and those relations are going to be physically real, and therefore you get some physically real dynamics for the partial observables, even though those observables are not individually real. So the example that Rovelli gives is when we're trying to sort of spell out the dynamics of a pendulum in the laboratory, we're not just going to observe the position of the pendulum. What we actually do is look at the position of the pendulum at various different times. So the dynamics we arrive at is, in fact, made up of complete observables in terms of the relation between the position of the pendulum and the reading on some clock. So this seems like it is a good way to solve the formal problem. We can, using this method, get out structures which look like the kind of structures we expect to see in classical and quantum physics. But there's a further question about whether this can solve the experiential problem. So the question is, can we actually observe these observables, and if so, how do we do that? I will also, a little bit later, talk about quantum reference frames. This is sort of another approach to to extracting the right kind of structures out of these theories using relational quantities. So in the quantum reference frames formalism, what we do is we choose some subsystem of the universe, we use that subsystem as a reference frame and describe goings-on relative to that reference frame. The thought is that the description we then get kind of looks like it's made up of partial observables which should not be physically real, but in fact all of those partial observables are relativized to a reference frame, and so we're really giving a description in terms of complete observables which are physically real, and the dynamics we thus get can in fact be regarded as physically real. The most well-known example of this is the Page-Wootters formalism, in which the reference frame is a quantum system which can be treated as a clock, and we can show that if it's an ideal clock with certain nice properties, then quantum systems described relative to that clock will undergo the usual Schrödinger evolution. So what we find is that we have indeed extracted the usual dynamics of quantum mechanics out of this formalism. So again, this looks like a nice solution to the formal problem. We have extracted the structures we wanted, but again, there's a question about how exactly we as observers are supposed to observe these things. Okay, so I'll focus on the partial observables in the classical context for now, and I'll return to quantum reference frames later. So Rovelli gives the sort of following heuristic description of how it is that we observe his complete relational observables. In this case, where we're trying to look at the dynamics for a pendulum, we're going to need two measuring instruments, one giving the position of the pendulum, one giving the time, and the theory won't predict either of those things individually. The reading on the position is not a complete observable, the time is not a complete observable, but the relations between them are, so we can observe the relations between them, and that's how we get dynamics for the pendulum. So Ehrman raises some concerns about exactly how this is supposed to work in detail. The worry is that however we measure this relational observable, we can't do it by first looking at the value of the position and then looking at the value of the clock and then somehow comparing those things. That's because, according to the standard interpretation, the position is not real on its own, the time is not real on its own, so you shouldn't be able to measure those things individually and subsequently compare them. Your measuring procedure is somehow going to have to be sensitive directly to the relation between them. And that seems a bit odd because, at least intuitively, it seems like what we do in a laboratory when we look at pendulums is, in fact, observe one thing, observe the other thing, and then compare them. It's not obvious that the measuring procedure is, in fact, directly responsive to the relation between them. It seems like we measure them individually. So Ehrman's worry is that it doesn't, although complete relational observables are physically real, it's hard to understand how we actually could possibly observe these things. So Maudlin is not very impressed by Ehrman's worries here. He describes a slightly different scenario in which we're trying to establish the value of the stress energy tensor at the point where some geodesics coincide. And he says, clearly we are able to measure this. What we'll do is something like send a rocket along each path, observe where they collide, and then make the measurement at that point. And it seems that nothing in Ehrman's argument suggests any difficulty about this procedure. And I think Maudlin's description here is suggestive, and I will come back to it, but at least on the face of it, I'm not convinced this fully resolves the problem that Ehrman is talking about, because it still sort of seems that in this procedure, what you have to do is first observe the rockets colliding, subsequently observe the reading on your stress energy tensor measuring device, and then compare those things. You certainly can't put your stress energy tensor measuring device at the exact same location where the rockets collided, because that space-time point is already occupied by the rockets colliding. So it does still seem like there are two separate observations being made here that you, the observer, have to combine somehow. So again, there's this question, how can we actually do this if those things are not individually real? So one way you can respond here is to interpret Ravelli as just opposing the standard interpretation and saying that partial observables are physically real after all. So Rickles does suggest that this is how we should interpret Ravelli. He suggests both spaces, both the space of the genuine observables and also the partial observables, are invested with physicality by Ravelli. The partial observables in particular are taken to be physical variables. So that, if true, would be a fairly radical move on Ravelli's part to tell us that the partial observables are real, physically real, despite failing to be diffeomorphism-invariant. But I don't think we necessarily have to read Ravelli that way. So sort of looking back at the concern that Ehrman raised, something that I noticed about that description is that Ehrman sort of seems to envision the observer as being external. There's a sort of picture in mind in which the observer is looking at the universe, observing a partial observable in one place, observing some other partial observable in some other place, and then combining those things. And that indeed seems like it shouldn't be possible because the partial observables are not physically real. But observers, of course, are not actually external to the universe. Observers are there in the universe, and that surely has something to do with the way in which observers are able to measure or observe partial observables. So sort of just heuristically thinking about how we observe the positions of objects, we are not observing them as partial observables. We're not observing them as sort of values of variables at abstract coordinates. Rather, we're observing positions relative to our own physical location. So when I observe the position of that table, I'm not observing something that would be changed by diffeomorphism, because what I'm really observing is the relation between me and the table, and that is something which is not changed by a diffeomorphism. So it seems to me that possibly a better way to interpret Ravelli here is to imagine him as suggesting that we observe partial observables in virtue of observing how they are related to us, because the relation between a partial observable and me is in some sense a complete observable, and thus it sort of makes sense that I should be able to observe that because that relation is physically real. So to make further progress on describing how we could observe partial observables, if we're supposed to do that by observing them relative to ourselves, we're probably going to have to say something about what we mean by ourselves, and that unfortunately probably means saying something about conscious experience. I have no desire to try to solve the hard problem of consciousness here, so I'm not going to say anything very detailed about consciousness. I'm just going to adopt what I think is a fairly reasonable criterion for the way in which conscious experience makes contact with the physical world. I'll call that the reality criterion. It simply says that conscious experience cannot supervene on or have direct access to any physical fact which is not physically real. That's written in a slightly awkward way. The reason it's written that way is because I wanted to write something which is plausibly acceptable both to physicalists and to dualists. So I don't necessarily want to rule out the possibility that consciousness could depend on some non-physical thing, as the dualist would have it. But I do think that dualists should agree that in terms of access to the physical world, consciousness will only have access to physically real things. And similarly, the physicalists should say consciousness can only supervene on physically real things. So in particular, the point of this is to say that if we're interpreting gauge theories and diffeomorphism-invariant theories in the standard way, that means that consciousness should not supervene on or have access to partial observables. It should only supervene on or have access to complete observables. So what does that mean if we're trying to describe how it is that an observer actually comes to observe a complete observable? Well, one starting observation is to say that when we make an observation, clearly that involves something like the brain of the observer becoming correlated with a feature of the environment. And the relation between the brain and the environmental feature seems like the kind of thing which is probably a complete observable. So that looks like good news. It looks as though we could say, well, consciousness is going to supervene on or have access to these relations between the brain and the external world. Those are complete observables. That satisfies the reality criterion, so that's how we come to observe these things. But that approach does have some fairly odd consequences. It requires us to adopt what you might call an externalist account of consciousness, in which the content of my conscious experience right now depends not only on the state of my brain right now, but also on the world surrounding me. So that's, I think, quite a strong form of externalism. I want to differentiate it from perhaps a more common view, which is externalism about the intentional content of experience. It is quite common to suggest that the meaning or reference of our experience depends on the external world via something like a causal theory of reference, for example. But what would be needed here to make sense of consciousness supervening on these relations is not just externalism about the intentional content of experience, but externalism about the sort of information available in my experiences at any one time. And that is, I think, quite a counterintuitive view, which would potentially have some odd consequences. One difficulty is that it just seems quite difficult to square with our current understanding of consciousness and the brain. We have pretty good evidence that most of the content of consciousness seems to be very closely correlated with the state of the brain and not directly with the world surrounding it. In particular, many people have the intuition that you could take the experiences that I'm having now and replicate those experiences in something like a brain in a vat that you were just sort of sending appropriate electrical signals into. But if you really accept this kind of externalism about consciousness, you'd have to say that scenario is not in fact possible because my consciousness right now is in fact supervening on or accessing the relation between my brain and the external world. So if you take away the external world, you can't have the same experiences anymore. So maybe that's true, maybe that scenario is not possible, but I think that certainly goes against the way we currently think about consciousness. There's also plausibly issues regarding locality. If you really think the content of my conscious experience right now supervenes on or accesses the relation between my brain and things in the external world, you might worry that changes to things in the external world, I will immediately become aware of those things because the content of my experience are going to change, and then you're at risk of getting something like superluminal signaling if you're not careful about how you model that. So I'm not necessarily saying that the externalist view is impossible. I think you could potentially figure out models for it which would avoid some of these problems, but nonetheless it seems quite counterintuitive and not very consistent with how we currently think about consciousness. So for that reason I'm going to focus from here on internalist views and how you would proceed if you think that conscious experience should, roughly speaking, depend only on things going on in the brain. So the internalist view does seem to pose a sort of prima facie problem for the idea that we observe relational observables, because the thought that I can observe a partial observable relativized to myself sort of seems to assume that what I am observing is outside of my body and distinct from me, and that I can become aware directly of that relation. If the information has to be copied into my brain before I can actually become aware of it, it's not clear that there's any relation any longer. It looks as though we've taken away the relational part, and now we just have something like a partial observable inside the brain, which, according to the reality criterion, is not something I should be able to be directly aware of. So it looks like if we're going to make the internalist approach work in this relational context, we're going to have to identify some appropriate complete relational observables which can be located entirely within the brain. So one obvious way to do that is inspired by kind of the Page-Wish's style approach. That would involve identifying some subsystem of the brain which plays the role of a clock. And then we could identify what I call psi at t variables, where we say the rest of the brain is in some state psi relative to the internal clock being in state t. That relation is a complete observable. That is the kind of thing that consciousness could supervene on or have access to according to the reality criterion. So it looks like if we say that consciousness just directly supervenes on those kinds of psi at t variables, that gives us a way to become aware of partial observables in virtue of them being copied into our brain and then bearing some relation to our internal clock. But there's still, I think, a bit of a prima facie problem here, sort of highlighted originally by Ehrman, who notes that these kinds of coincidence variables are timeless, right? If it's true that my brain is in state psi conditional on my internal clock being in the state t, then this is always true, timelessly and eternally. So if the foundation of my consciousness is these kinds of psi at t variables, it seems a bit mysterious why I should have the experience of being localized at a time. And in particular, there's no obvious reason why a conscious awareness could not be simultaneously aware of two or more psi at t variables within the same experience. There's nothing sort of mutually exclusive about knowing more than one of those timeless variables at the same time. So it's sort of not obvious why in this kind of approach consciousness should end up being localized at a single time rather than having awareness of two or more times simultaneously. So Taybolt makes a sort of similar point in his discussion of the problem of time. He notes that if the partial observables are non-measurable, then we seem to lose our ability to use different values of the internal clock to describe change, because it's not obvious how we could sort of experience being located at one time and then later experience being located at a different time. Or we seem to have our measurements of these complete observables, which are temporally non-local, they're timeless and eternal, so we don't seem to have any meaningful sense in which we should be localized at a single time. So to understand why we don't have the experience of being kind of spread out along our whole life's timeline, I think it's helpful to sort of take a step back and try to imagine what it might be like to have that kind of sort of all-at-once knowledge of an assortment of psi at t variables spread out across your whole life's timeline. So this is an image from the movie Arrival, which is based on the lovely short story by Ted Chiang, in which he tries to envision exactly this possibility. This is quite common in science fiction. Kurt Vonnegut does it as well in Slaughterhouse 1984. So looking at these various thought experiments, one thing you can sort of distill from them is that having this kind of all-at-once knowledge of your life's timeline necessarily limits the sense in which you can be meaningfully an agent. If, for example, I know that on Tuesday I will be eating a cake I baked on Monday, I cannot possibly refrain from baking that cake on Monday because I can't eat it on Tuesday if I didn't bake it on Monday. So having knowledge of what's going on Tuesday, in some sense, limits my agency on Monday. I have less choices about what I could possibly do on Monday. The sense in which I am meaningfully an agent seems to decrease with my knowledge of the future. So more generally speaking, there seems to be a sort of trade-off between knowledge and agency. Ismail writes very eloquently about this. She imagines a computer at which you use and you ask the computer to predict its own outputs. And the computer isn't going to be able to do that because by saying things, the computer is doing things, and that keeps it from being able to stabilize the facts it is representing independently of how it represents them. That is, if the computer is really exercising agency, it can't possibly know for sure what its outputs are going to be before it's decided on them, because in that case it wouldn't really be exercising agency any longer. So sort of generalizing that, the thought is that if an agent is contemplating an action at time t in a sort of meaningful way where they really have agency, they can't in general have reliable knowledge of their states at times later than t. And similarly, an agent cannot in general simultaneously make choices about actions occurring at two separate times on their world line, because the later action will take as inputs to that deliberative process facts about the earlier action, and so the fact that you have the choices about the later action means that you necessarily don't have many choices about the earlier action because you must already know things about what choice you made. So the point of all this is that although a sort of passive awareness of psi at t variables doesn't seem like the kind of thing that needs to be localized at a time, agency for sure does seem like the kind of thing which, roughly speaking, needs to be localized at a time, or at least quite limited in the way in which it is spread across time. It doesn't seem like you can meaningfully conceive of an agent which sort of simultaneously exercises agency at all the points in its life timeline. So what I want to suggest, therefore, is that difficulties with reconciling the reality criterion with the nature of our temporal experience potentially reflect an overly narrow focus on consciousness as a kind of passive awareness. This is quite common, and you can see, for example, in standard accounts of the temporal asymmetry of agency. The standard accounts treat passive awareness of the state of one's brain as sort of central to consciousness, and thus often regard agency as some kind of illusion resulting from asymmetric knowledge of the past and future. You sort of think that you're an agent because you know more about the past than about the future, but really your passive awareness of the values of the variables is what consciousness is really all about. The agency is just kind of a mistake that you arrive at because of this asymmetry in your knowledge. So what I want to suggest is that plausibly awareness and agency just can't be cleanly separated in that way. It's not reasonable to think about consciousness as being purely passive awareness. You need to take account of the agential nature of conscious experience. So in particular, what the standard account does, I think, is sort of start from the assumption that observers are localized at times, look at the information available at that time, and thus kind of derive an illusion of agency. Whereas if you sort of start from the perspective that consciousness is necessarily agential in nature, you can then kind of arrive at the conclusion that consciousness must end up being localized at a time rather than taking that as your starting point. Okay, so there's obviously a lot more that one could do to sort of flesh out that account of the relation between consciousness and agency, but I won't do that here because we're supposed to be talking about relational observables. So going back to relational observables, I want to suggest that this agential conception of consciousness suggests a different way of choosing the right kinds of relational observables in the brain. So rather than focusing on something like a psi at t observable, you should instead be focusing on something like the temporal relation between inputs and outputs, where the input is something like an observation, memory, or thought, and the output is a choice of action. The relation between those seems like the kind of thing which could be a complete observable, so it's suitable for consciousness to access or supervene on. And also just sort of based on my own introspection, that does to me seem like the right kind of variable to represent the nature of conscious experience. It seems to me that experience is kind of a sequence of receiving inputs and deliberating and deciding how to act on the basis of those inputs. So in some ways, this does seem like a sensible way of representing the way in which our consciousness accesses the world. So that suggests something like the following story for how it is that we come to observe relational observables. Basically, it ends up being a sort of a long chain of relations between things, and some of those relations are agential in nature, and those are the parts that our minds have access to. So, for example, we can imagine Alice's brain becomes correlated with some partial observable in the environment. So there's some complete relational observable here relating that environmental variable to the partial observable in Alice's brain. There's then a process of deliberation in Alice's brain taking as input that partial observable and producing as output a decision that she will measure some variable of a system, so that the relation between the input and the output is again plausibly a complete observable. The decision then produces bodily motions. Those act on the system and produce a measurement outcome, which again will be a partial observable. Alice's brain becomes correlated with that partial observable. And so what we have internal to the brain is something like two sort of chained complete relational observables. One is the relation between the initial observation and the decision to make a measurement. The second is the relation between the decision to make a measurement and the later observation, which is another partial observable. So roughly speaking, what Alice observes is something like the value of the variable v is v relative to the clock c showing time t. But those partial observables get chained together by the agential processes that Alice engages in when she makes the observation, decides to perform a measurement, and does so. So what I want to suggest is that this agential conception of how we observe partial observables is arguably in some sense already implicit in Ravelli's original definition of partial observables. So Ravelli specifically defines them as variables to which we can associate a measuring procedure leading to a number. So he's not defining them as variables which we just become sort of passively aware of. They're variables that we actively engage with, that we do things to, and plausibly it is that active process of engagement which is what allows us to observe them. I also think that the description I've just given is a pretty good match for what Maudlin tells us about how we actually measure tensor fields in space-time, because what Maudlin describes is an active process in which we observe the collision of the rockets. We use that as an input to our deliberation in which we decide to make another measurement, and the result of that measurement is the reading on the tensor field device. So the way in which the collision and the tensor field reading get linked together is precisely by an agential process that we actively engage in, and it's that which links those things together and gives us the complete observable. Okay, so having said all that, I can finally arrive at quantum mechanics. So I'm going to assume here that we're working in a context where unitary quantum mechanics is presumed to be universal. That's because that is the context in which the problem of time arises. So obviously, if unitary quantum mechanics is universal, that means we're going to have to model all of these agential processes in quantum terms in some sense. We don't have recourse to just move to some sort of classical regime and have the agential processes take place in the classical regime. Now, in a sort of passive awareness model of consciousness, it's not sort of that hard to put agents into the picture. You can sort of just make do with an operational interpretation of the quantum state, where you think of mod-squared amplitudes as representing probabilities for agents to become passively aware of various values for things. But this is not obviously going to work in a more agential conception of consciousness, because if you want to model the agent as an agent, then you have to go on modeling the agent after the observation is complete. You have to model their deliberation that follows their observation and the actions that they subsequently take. So it's not enough, therefore, just to have a sort of passive interpretation of mod-squared amplitudes as probabilities. You do have to be able to properly model the whole agential process. And here, of course, we just run headfirst into the measurement problem. We can, of course, give an external description of this. In the setting where we're taking unitary quantum mechanics to be universal, we're going to have a description in which Alice measures some system, and Alice and the system then end up in some kind of joint superposition of all of the possible outcomes. And so this seems to lead to problems if we want to then model agency, because kind of the point of the measurement problem is that this state doesn't look like it represents Alice as having any definite experience, so it's not obvious how you can then go on to model Alice as taking action based on the outcome of her measurement. All of which is to say, it seems to me that we are surely going to need to adopt some solution to the measurement problem before we can have any hope of modeling agency in this way, and therefore I am skeptical of the idea that the problem of time can be fully addressed in an interpretation-neutral way. It seems to me that you are going to have to adopt some account of observation and agency before you're going to be able to properly explain how the structures you have extracted in your solution to the formal problem can actually make contact with someone's conscious experience. So finally, I want to talk about what the quantum reference frame formalism adds to this. So you might perhaps initially hope to avoid the need to adopt some solution to the measurement problem by using the quantum reference frame formalism. You might, for example, hope that by switching into Alice's reference frame, you will then be able to get some account of what Alice experiences, which can be used in an interpretation-neutral way and can be used to model Alice's observation and agency. But unfortunately, I don't think that switching into Alice's reference frame really achieves that in the way that you would need. One problem is that switching into Alice's reference frame just means that you are now describing everything relative to Alice's physical body. You're not necessarily saying anything about what Alice will see, For example, we can, of course, describe all of the things behind me relative to my physical body, but that doesn't mean I'm seeing them right now. So simply the description of something in Alice's reference frame doesn't automatically mean that she's having any corresponding experience. Furthermore, switching into Alice's reference frame is deterministic, so the state that she will assign to the things in her environment will always be the same under this procedure. So in particular, if we look at the superposition state on the previous slide and then try to understand Alice's experience by switching into her reference frame, then either we've got to say Alice sees all of the outcomes, or we have to say Alice sees one outcome, but it's the same outcome every time. The latter possibility looks empirically unacceptable because we know that, in fact, Alice sometimes sees one outcome and sometimes sees the other outcome. So it looks like the only option we have here really is to adopt the approach where we say Alice sees all of the outcomes. So the quantum reference frame formalism, therefore, doesn't really seem to save us from having to adopt a solution to the measurement problem, because the only obvious way to make sense of it is to adopt the Everett interpretation and say that Alice sees all the outcomes. So the quantum reference frame formalism on its own doesn't seem to solve this problem. Indeed, the only obvious way I can see to make sense of how to model agency in this picture is to adopt the Everett interpretation. All of the sort of neo-Copenhagen style approaches and cubist approaches don't seem to give us the resources we would need to actually model Alice making an observation and then going on to act on it in various ways. So it looks to me like the Everett interpretation is the only straightforward way to proceed here. That's not good news for me because I don't think the Everett interpretation is right. So I think there's a problem here. But even if you do think the Everett interpretation is right, I think there are still some issues to be resolved. Because it's not clear to me that the quantum reference frame formalism specifically is the right way to approach the adoption of an internal reference frame. So it does seem true, I think, to say that to solve the problem of time, we're going to have to do something like adopting an internal point of view on the universe that represents the experience of an individual agent and then show how that individual agent can experience change, even though there's no sort of change at an external level. And I just don't think that switching into the agent's reference frame is necessarily the right way to adopt that internal point of view. So the worry is that what we do when we switch into an agent's reference frame is just remove the agent from the description entirely. So in particular, the position and momentum of the reference frame are not considered dynamical variables in their own reference frame. They're just totally removed from the description. And that seems to mean that we can't really model an agent as an agent in their own reference frame because we have taken the agent out completely. We can't model them as taking any action because they're just not there in the description at all. So basically, the conclusion I want to arrive at here is just that if it's true that having some agential conception of consciousness and awareness is important to observing relational observables and to solving the problem of time, then the quantum reference frame approach, as it is currently formulated, is maybe not the right way to approach this problem of adopting an internal point of view because it doesn't allow us to sort of take seriously the agential nature of the observer. So I don't, unfortunately, have a concrete proposal for what an alternative would look like, but I guess it's a question that I leave to the room. Is there some alternative way that we could model the adoption of an internal point of view on the universe, which does better at allowing us to actually treat the agent as an agent rather than just removing them from the picture entirely? So to conclude, I think that in order to understand properly how we're able to observe relational observables, it is important to take seriously the fact that agents are not just observers, but also agents, and that they engage actively with the things that they are measuring. And I think, therefore, that there are some problems with the approaches to the problem of time that we currently have available to us because they don't seem to take seriously the agential nature of the agent in the right kind of way. Thank you, and I guess we should see if we have questions. Yeah, I mean, so none of anything I've said was necessarily supposed to be in the context of relational quantum mechanics. It was just supposed to be sort of reflecting on if relational observables are the right way to solve the problem of diffeomorphism-invariance in the classical case and the problem of time in the quantum case. For sure, there needs to be some story that we can tell about how we observe them. So I don't think that, I'm not trying to suggest that consciousness needs to be a sort of intrinsic part of the ontology or to be a fundamental primitive or anything like that, but certainly consciousness will have to appear at some point because we need to understand how we ourselves as observers actually gain access to the world. So the issue I'm trying to address here is not the measurement problem specifically, but rather the sort of epistemic problem of how do we as observers get access to these kinds of theories that have these diffeomorphism symmetries. That's why I'm talking about consciousness, not because I think it's fundamental, but because it's clearly important to the epistemology. Yeah.
David?
Thanks. A somewhat similar point, probably from about a different angle. I mean, it's not obvious to me we have to engage in consciousness here. I mean, I consider it's the case you want to engage in something like agency and detection, but
Yeah.
I mean, look, the trivial way to make my point is that most of our measurements are made by robots anyway.
Yes.
But even those that aren't, it's not obvious that what we need to model is a human who happens to have complicated conscious states rather than just a device that's capable of measuring things. And it feels as if really what's doing the work in the story here are notions of content fixation and agency, which sure, on some approaches to philosophy of mind, are downstream of consciousness.
Yep.
But that's a pretty substantial addition to philosophy of mind at the moment.
Yeah.
And it feels like we need to be able to just bypass the diversion via consciousness and just go directly to what does a system need to do to constitute recording a result.
Yeah.
And that feels like something we can engage with, to some extent, philosophy of mind tools that connect sort of action and contemplation, but without having to get sort of into the consciousness.
I mean, I agree that to some extent what you want is a specification of a system recording a result, but I'm not convinced that you can fully tell the story without saying at least something minimal about consciousness, just because I think that ultimately what we are trying to explain are results that impinge on our conscious experience, and to understand that you do need to say something perhaps very minimal about how conscious experience latches onto the physical structures that you're describing. I certainly don't want to solve the hard problem of consciousness or do any of that kind of thing, but I do think that you do need to have some story about what parts of physical reality are plausibly accessible to consciousness.
Okay, but just to flag that there's a substantive philosophy of mind assumption there. I mean, suppose I'm down it, and I want to say that content is prior to consciousness.
Yes.
What we want to know here is how does one form the belief that the space-time curvature is blah.
Yes.
Now again, on a content prior to consciousness line, consciousness doesn't get a look in there. Belief is content fixation is prior to consciousness.
Yes.
There might be a subsequent philosophy of mind question as to how I become conscious of that fact, or indeed even what that means.
Yeah.
But on that kind of philosophy of mind, then we can talk about beliefs and it's not epistemic updating and things without ever touching consciousness. But you don't need to buy that note of philosophy of mind. I'm just using the illustration.
Sure.
That
And I mean,
there's a substantive philosophy of mind commitment.
For sure, and I mean, I think I don't buy that approach to philosophy of mind, but also I think much of what I would say would be substituted in that case with replace consciousness with belief or whatever awareness or whatever you want to use to represent the impinging of empirical experience on our awareness in such a way that we can use it as evidence.
Well, again, awareness is to move towards consciousness. The relative idioms here are intentional. They're belief-type idioms. One might have a further philosophy of mind that says that belief requires awareness, more generally that content is subsequent to consciousness. But that's substantive.
For sure, and I think most of what I say would go through just fine if you just replace consciousness with belief.
I think that's right. I mean, in a sense, I think you could tell a more neutral story that looked at the intentionality side of this, and then the consciousness bit would work out fine.
Yes.
If one had the right kind of philosophy of mind.
Yeah, I mean, I told it this way because I don't find that account of experience very compelling, but I agree that you could plausibly replace most of the reference to consciousness with something more neutral, and you would get a very similar story, I think. Yeah.
What?
I think it's again related, right? So I was wondering, could you have like a purely theoretical reading of values partial observables, where you say, I have that theory, it's diffeomorphism-invariant, and this is a way how I theoretically can remove the diffeomorphisms from my code.
Right.
Then the second question would be, how do I relate that to my experiences?
Yes, that's why I had the formal problem, the experiential problem. So your theoretical reading solves the formal problem, but then there is still the experiential problem.
Yeah. And then, could you say, if you have done this first step of the process, could you then say something about, like, for example, perihelion of Mercury, without saying anything about, like, how we actually observe the perihelion of Mercury through our telescopes?
Oh, for sure. I mean, I don't think you want to say that everything you want to describe by the theory must always be related back to an observation, because I think, we often want to apply our theories to describe things that nobody is directly observing. What I'm concerned with more here is the epistemology. In order for the theory to make any sense, we have to be able to say that there is some way for observers like us to gain access to it in some form. And so the question is, how does that happen? But it doesn't necessarily, I'm certainly not saying that every meaningful observable must be observed. Yeah.
So my questions now become a finger, because it was originally the same one as David.
Yeah.
But let me try to see a little bit further what the implications are for the argument.
Yeah.
So suppose that we would resist the move to internalism about accessible information, and really, give a thoroughly externalist account of all of that. That's necessary. If I understand your argument correctly, that would mean then that the relational approach doesn't face the same sort of difficulties, and there would, at least we hope, it seems to me, to solve the problem of time without necessarily have to solve the measurement problem. Is that right?
Ooh, interesting. I think it does look a bit easier on the externalist approach. But with that said, I do think the externalist approach still plausibly faces the same problem about how we get localized at times, because again, there seems to be no obvious reason why one should not be simultaneously aware of the relation of my brain to the environment at one time, and then also the relation of my brain to the environment at some other time. So I think I would suspect that you end up with a similar dialectic where you still have this problem of how you get localized at times, and then you still need to introduce agency to make sense of that. So I think the externalist approach...
Externalist story.
Right, because the externalist still has this question of how does the agent end up being localized at a time?
Sure.
And I think agency is the answer to that. And sorry. Yeah.
And agency, regardless of whether understood externalist or internalist way, that really requires the measurement.
It seems very difficult for me to see how you could meaningfully model agency in a quantum context without adopting some solution to the measurement problem.
Okay.
Yes.
Okay.
Thank you for the talk. I want to see if you can clarify for me the following. We started with the problem that observables are not diffeomorphism-invariant, and therefore we normal observables, we think that observables are not diffeomorphism-invariant, so there shouldn't be considered observables. And then we replace this by arguing that what we are going to look is at correlations between observables.
Yes.
The question to me is, how do you establish, how do you measure, how do you detect the correlation between observables without observing each individual
exactly. Yes.
entity and finding that they are indeed correlated?
Yes. That was the question I was trying to answer. Were you not satisfied with the answer?
I'm sorry.
I'm not quite sure what question you're asking.
Yeah. Again, how? We're not supposed to be able to measure individual single observables, but only relationships between them.
Yes.
By their correlations. How do we establish or detect the correlations without observing the original entities that are supposed to be correlated.
Okay, well the story that I was trying to tell here was just to say that our observation, our experience, however you want to describe it, supervenes on or has access to relations directly and not to the individual.
But how is that possible? How do we experience relationships without experiencing the objects? That's my question.
Well, my suggestion was that our experience is agential in nature, and so the relationships that we experience are the relationships between the inputs and outputs of agential and deliberative processes in our brains. So our experience is an experience of receiving an input and producing an output.
Okay, but then we have to perceive the input, perceive the output, and see the relations.
Well, no, I think that's precisely the mistake that comes from adopting a passive awareness model of consciousness where you are separately passively aware of the values of things. I think that the agential model says that the experience inheres in the relation and not in the individual values. So you can't actually separate out the input and the output. They are necessarily tied to each other, and it's the relation between them that you experience.
Okay, then we have Tim.
Thank you. Thank you very much for the talk. I find it very interesting, and I do agree that the question of how relational observables, but actually also relative facts and relative interpretations in context of experience is very important and underexplored. There was a lot of process, so maybe what I'm about to say doesn't make any sense, and if that's the case, I apologize in advance. But I was wondering whether there is an assumption in your reasoning, or a premise in your reasoning, the assumption that our experience is in some sense itself unique, or at least non-relational, if that makes sense. So you were discussing the extremist picture where you said maybe our experience supervenes on these computer observables that are correlated between things in the brain and things outside of us.
Yes.
But that doesn't seem to be quite the same thing as to say maybe our experience itself is, if you want to call it that, partial observable and also complete observable. And if you really want to talk about something complete, you have to talk about our experience itself in relation to something else. And one simple way to bring this question into focus is, I think, if you assume, just as a toy case, a very simple identity view about brain states and states of consciousness, then it seems that anything you may want to say about the state of the brain carries over to the state of consciousness. And I wonder whether that somehow would change the story, or whether that assumption somehow enters into your story.
So I think one of the things I'm doing is specifically denying the simple identity theory between brain state and states of consciousness, precisely because I don't think that states of consciousness should be able to supervene on or have access to things that are not physically real. That was the reality criterion, and therefore, insofar as you think of the state of the brain at a time as being a partial observable, consciousness can't supervene on or have access to that. And I can kind of see that another possible way out of this would be indeed to say that consciousness does supervene on a partial observable, but consciousness is relativized to something. I just find it really hard to understand what it would mean to say that consciousness is relativized to something else, but maybe that's just a failure in my imagination. But because I find that very unintuitive, I prefer this route personally. But for sure, that seems like another interesting thing to explore.
Thanks, that's great. Because my question is overlapping with the definition. I was a bit surprised when you talked about consciousness like that. And I was wondering what would change if you replace consciousness by intentionality. In the sense that, well, you know what? Some people think that we can functionalize intentionality and we can eliminate qualia. Other people think that we need both, but philosophical zombies are possible, so there could be physical duplicate of us with the same beliefs, but with no qualia attached to those states. So what will change in your view? I think for you it's quite important to have consciousness, but is that really, are we
Okay, so yeah, two responses. One is that, yeah, much as I said to David, I think a lot of what I said here, you could just replace consciousness with intentionality and it would just go through exactly the same. I used consciousness because that's how I personally think of the epistemology as a question about how knowledge of the world arrives at my conscious experience. But if you don't think of epistemology in that way, I think you could replace this with intentionality and not lose too much. With regard to the specific idea that the relations in question are the relations of intentionality, I worry that that leads to the same kinds of problems as the externalist view. It seems to suggest that the content of my knowledge or experience right now depends in some way on relations to the external world, which does seem to lead to potentially problems with locality and also potentially problems with consistency with the evidence that conscious subjective experience, or intentionality if you want to replace it, seems to depend wholly on factors internal to the brain. So I'm not necessarily saying that route wouldn't succeed, but for the same reasons that I was suspicious about externalism here, I would also be suspicious about that.
I think externalism is more popular than making something, because...
No, but I really want to emphasize that the externalism I was talking about is not externalism about the content of experience. Because I do believe in that kind of externalism. I think that's a very reasonable view. But the issue here was not about the meaning or reference of the experience, but the sort of accessibility of information. And that's where you get kind of problems in terms of locality if you have access to information that's not stored in the state of your brain.
Well, I just wonder if a little dose of behaviorism would be helpful here. I mean, you were talking about things like, what's intuitive about the degree to which my mental states can supervene on various forms of physical, what's physically real, or whether or not my mental state has to supervene on what's physically real.
Yeah.
What I can record on a physical substrate
Yeah.
had better depend on what's physically real.
Yes.
Just on physical grounds.
Yeah.
And again, I think fairly neutral to the philosophy of mind. Science is a public activity.
Yes.
And the recording of data is a public process. It has to be done in physics. So can we bypass this question about whether my mental experiences has to supervene physical things and just say that my record, my lab notebook has to do that?
I'm not personally convinced, because I think there's a further question about the relation between what's written in the lab notebook and my conscious experience, and ultimately I'm concerned about conscious experience as being the primary source of empirical evidence. I don't think lab notebooks are. And I certainly do agree that you would then expect the story that you arrive at to give a sensible account of the relation between conscious experience and lab notebooks and the experience of other agents, and I would expect all that to be unified appropriately by an acceptable theory. But I don't personally see a viable route to eliminating experience entirely because of the way I conceive of the epistemology of science.
I suppose my point is that if I've got a story of the epistemology of science that goes as far as giving a full account of how the public activity of science
Yes.
is in the business of recording data or observables in the way we want it to do.
Yeah.
At that point, we can dump the connection between the public activity of science and our conscious experience of scientific epistemology, if you like, into the philosophy of mind. It feels as if one can do a sort of division of labour where getting the public facts right is sufficient for the philosophy of physics, even if there's a further philosophy of mind question.
I'm not completely convinced by that, partly because I worry that the relation between conscious experience and the physical world is particularly in this kind of context, not perhaps different to how we have traditionally conceived of it. And my worry is that by totally disregarding the question of how conscious experience makes contact with the physical world, you may miss important factors that are needed, for example, to understand the nature of temporal experience. I'm skeptical that you could fully account for the nature of temporal experience saying nothing at all about consciousness, particularly if you're working in a context where it seems difficult to get any meaningful notion of time or change without first adopting some internal point of view. So from that point of view, I'm concerned that leaving it all to philosophy of mind potentially misses points which might in fact be relevant to physics.
We still have time for more questions if you have. No? Then join me in thanking